In this video, we're going to talk about the different ways that we can display data by using different types of representations. So there are many different ways that we can represent data. And in this video, we're going to focus on 8 different types of ways that we can represent data. The only way that we're not going to focus on is this box and whisker plot. And that's because we're going to focus on that in a separate video, talking about how we actually come up with all of the values to create a box and whisker plot. It's a little bit more involved. But by the end of this video, you should know how to display the other 8 and use the information to create an accurate representation of all 8 of these different types of representations. So the first way that we typically represent data is using a frequency table. And a frequency table is a method for organizing data, and it typically displays a series of scores together with their frequencies. Now this can vary depending on what type of data you collected and how the data is grouped, but this could be something as simple as, we have a table of test scores. And let's say in that table of test scores, we have our grades that students received in one column, and we have the number of students in the other column. So notice that we have data grouped together along with their frequencies. So say the grades were A, B, C, and D, and say we had, 10, 15, 5, and 3. Something like that. Now, typically in a frequency table, you have things in a specific order. So the order will typically go, from high to low or low to high. You can also have a frequency table that looks something like this. So say instead of test scores grouped as A, B, C, D, maybe you wanted to look at it a little more closely. So say we had, test scores in a different way. Say we had ranges instead. So maybe we have, 100 to 95. And then we have, 94 down to 90. And then we have 89 down to 85, so on and so forth. So this is another way we could do it by grouping them into little categories like that, and then having the numbers of that particular score as well. So a frequency table is just a way of organizing that data, and it displays, scores or those little categories that we have with frequencies, and typically it goes in order from highest to lowest or lowest to highest if we have something with numbers and orders. The second one we're going to look at is called a bar graph, and bar graphs show data in specific categories. Now, what's very unique typically to bar graphs is these categories are a non-numerical category. So it's not something like, a test score or a temperature or time. It's not numbers for the categories. It is, something non-numerical. So in this case, you can see we have a favorite class. So maybe we're just gathering data about people that's not numerical data. Number of students is numerical, but the categories are not. So with a bar graph, you typically have on the y-axis your numbers. So we need this to go up to 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we can label those every 1 or every 2, whatever works for you. And then from here, we just draw out each category and the data. So here we're going to have the math category. And the math category needs to go up to 7 because we had 7 students. So we go up to 7, draw that in, and then color it in. And then we repeat this process with English. Maybe we go over to English over here, and we make its own little bar. And English needs to go up to 8. So we're going to go all the way up to 8 and go back down and then color it in. And then we have science, which has 6 people, So then we're going to draw science out. So science is going to go up to 6, over and down. And then we have our last one, which is social science. So that one will go up to 5. So I'm just going to put SS for social science, go up to 5, and draw. So you can see the categories, we give each little category a space on the graph, the order in which doesn't matter, and then we just draw out the representation of how many students they have. So this is used for categories that are non-numerical. So the next thing that we have is a histogram. And a histogram and a bar graph look similar, but they represent different types of data. So a bar graph represents data that is categories that are non-numerical. Histograms show frequencies of data values in intervals of the same size. So what you're going to notice about this histogram is that all of the categories are the same size. Notice they each encompass 3 numbers, and these categories need to be numerical categories. So a bar graph has non-numerical categories, histograms have numerical categories, and they are all the same size. Now, it's kind of the same process here. These y values are the frequency, so we're going to go along the y-axis. So we have 1, 2, 3, 4, 5. Then from here, we're going to have bars kind of like our bar graph, but those bars are going to be categories. So here, this category is going to be 0 to 2. This category is 3 to 5. This category is 6 to 8. And this category is 9 to 11. So we can see that we have categories that are all intervals of the same size. And then we're just going to draw the bars up to the numbers that they need to go to. So 0 to 2 books was from 0 all the way up to 5. So this one's going to color in here. Then the next one, 3 to 5, is at 4. So I'm just going to draw a little line out and go down so we can see that one. And then 6 to 8 was only at 1. So that's going to be a little bit lower. And then finally 9 to 11 was at 3. So that needs to come up. So you can see that the little intervals, they actually kind of connect to each other. They are touching. And then you can kind of track what happens over time in those different intervals. So for the different intervals of books read, you can compare and see which number of books was the most popular, which was least popular, etc. So our next representation is a dot plot, and it shows the number of times each value occurs in a data set. So this particular type of representation essentially uses a number line. And what we're going to do is on that number line, we're going to represent all of our different little categories that we have. In this case, we have a height, and then we're going to represent how many of each there are by using dots above that piece on the number line. So here we have 5, 6, 5, 7, 5, 8, 5, 9, 5, 10, 5, 11, and 6 feet. So now what we can do is we can actually represent how many are at each height by using dots. So at 5, 6, I have 1. So I'm going to put 1 dot. At 5, 7, I have 3. So I have 3 dots. At 5, 8, I have none, so I leave it blank. 5, 9, I have 2. 5, 10, I have 1, 2, 3, 4. 5, 11, there's 1, and 6 feet, there's 1, 2, 3. So again, just a different way to show how that data can be represented so that you can see how it is spread out and where there might be groups of numbers that are higher, lower, and you can make some interpretations. The next one we're going to look at is called a stem and leaf plot. A stem and leaf plot orders numerical data and shows how they are distributed. Now, what you have to remember about stem and leaf plots is you have to make kind of a key to represent how the numbers are going to be represented in the graph. What I like to do is at the bottom, I make a little note, and here I notice with my stem and leaf plot that I have all numbers that have a tens place and a ones place. So what I'm going to do is for each number, so say we have the number, 95. what I'm going to do is I'm going to split it into the tens and the ones spot. So here a 9-5 is equal to 95. And as I put them into the table, I'm going to be representing them in this way. Now, what I need to note is that in my table, I need to go from the lowest number to the highest number as I represent them in this stem and leaf plot. So I'm going to start with my lowest number here, and that's 40 from all I can see. And 40 I'm going to represent by putting a 4 here, followed by a 0. So that's my first stem and leaf paired together. Then I look for my next number, and I notice that I have 58. That's my next highest. So I put 5 split into 8. Then I look for my next number, and I see 62. So we have 6, 2. Then I find another 62. So this is where we get stems and then multiple leaves. So here we already have the stem of a 6 for the 60 part. So we're going to just put a 2 after it again to say that there were 2 62s. Then from here we keep looking, we see a 68, so we're going to do, again, another leaf off of that stem, so we have 68. Now I've exhausted all my 60s, so I'm going to move on to 70. So here I see a 75, so I have a new stem with a leaf. Then I have 79, so that goes off the same stem. Then I move up to 80s. So 82, then I have another one with the 4, another one with the 4, and a 6. Then I have 3 92s I need to account for. So I'm going to have 9, 2, 2, 2. And then also I'm going to have a 96. Now as I'm doing this, realize that I have an 84 that I missed. So what I need to do is I need to add that in. So I have to remember that I had a 6 here, because these need to be in order. And I need to add in another 84. So sometimes that happens. You're making them, and you have to add a number in. Now these have to be in order, so you're going to have to place it into its correct spot. But now we've fixed that and added it in. Then we have 98, which we can add in, and then we have 100, so we can do 10 and 0. So this does take a little bit of time to create, but you can see again, now that we have our data in order and we can kind of see the distribution here, you can see where there are more numbers and less numbers since the data is grouped better. And you can also see that if you turn this on its side, it kind of looks like a dot plot with numbers because it's going upwards and it's showing you how many in each different category, the 40s, 50s, 60s, 70s, 80s, 90s, and 100s, you have. So in a circle graph, the circle graph shows data as parts of a whole. So we're actually going to draw out a circle graph, and each little pie piece matches the size that it would be in the real world. Now, in order to do this, we do have to do some math calculations. And the first thing we have to do is find our total number of students in order to create this. So if I add together 8, 10, 8, 12, and 2, I find that I have a total of 40 students. So then, in order to figure out which portion of the table I'm going to use, I need to figure out how much each portion represents. So I need to do this by finding a percent for each. So here I'm going to take 8 and divide it by 40. And if I take 8 and divide it by 40, I find that I have about 20% of that circle that's going to be accounted for comedy, because that's this first one here, 8 over 40. Now, the way to find the exact number of degrees is to take that 20%, which is 0.2, and multiply it by 360. So that gives me about 72 degrees on my circle. Now I multiplied it by 360 because there are 360 total degrees here. and I wanted to figure out what's 20% of 360. So I know that I'm going to use about 20% of my circle, or 72 degrees, so it probably looks something a bit like that. So there is my number of students that like comedy. Now, I can use this same one for romance because they have the exact same number, which is kind of convenient. So I'm going to do that. That was a little off. Let's try that again. So here is romance. So I note that each of these encompasses about 20% of the graph. Now, if I do 10 divided by 40 for my action movies, I find that that's 25%. And if I multiply 360 by the 0.25, that represents 25%, I find that this is going to take up about 90 degrees in my circle. So here I'm just going to draw a line straight across to make that 90-degree angle, and here I have my action movies all accounted for, and those account for 90%, or for 90 degrees, which is 25%. Then I take 12 divided by 40, that gives me about 30%. Then to figure out how many degrees it takes up in my circle, it's 0.3 times 360, which is about 108, so that's going to be a little bit more. It's going to be about right there. So this is my drama. So that takes up about 30%. And then finally, 2 divided by 40 gives me the little 5% that I have left. And if I take 0.05 times the 360 degrees that I have, I find that this takes up about 18 degrees. So it's a pretty small portion. This is our sci-fi. So we have all different percentages here. If you want to label your percentages, you can do that. So this was 25%, 20%, 20%, 30%, and 5%. But this is just a very visual way to represent this so you can see how the data breaks down and how many in each category you had. Now, scatter plots we've done before, and they show the relationship between two data sets, and you'll have ordered pairs in a coordinate plane. So here you can see we have data. We're going to have temperature along our x-axis. We're going to have sales along our y-axis. We would make a little key. We would probably have, 10 start here, and then it would be 12, 14, 16, 18, 20, 22, 24. We would then also have the numbers along the side, so say that's 100, 200, 300, 400, 500, running out of space here, 600, 700, and so on. And then you would plot your data. So I'm not going to plot all these points, but here we'd plot 12, 200. And we'd plot 13, 250. Then we'd plot 15, 320. 17, and it jumps up to 430. Then we have a 17 at 460. 19 is going to be at 550, and so on and so forth. So you'd plot all of these different points onto here, and then you don't draw a line, so no line gets drawn unless you're asked to draw a line of best fit. But really what we're going to see is we're going to look for data trends. So we look for what's happening as the temperature increases over time. Do sales have a general pattern? Do they go up? Do they go down? Or do they stay the same? Or are they kind of random? And just from these first couple points that I plotted, you can already see that the data trend is that as the temperature increases, the sale increases. So that's what we use our scatter plots for. And finally, we have our line graph, and a line graph shows how data changes over time. So here we start off similar to a scatter plot. We start off by plotting all of these points. So I'm going to start off by labeling the years. So say this is 2000, this is 2001, 2, 3, 4, 5, 6, and 7. And then we have our prices go up to 25,000-ish. So we're going to be at, 5,000, 10,000, 15,000, 20,000, and then 25,000. And when you draw a line graph, while you plot each point, you also draw a connection between them to show the data and how it moves over time. So in 2001, the value of the car started off at $24,000. So that's your first dot. Then in 2002, it had dropped to 22,500. So once you draw your second dot there, what you do is you actually draw a line. So instead of just drawing dots, we're actually going to connect each dot and draw the line that goes between them. So this is called a line graph because you draw the lines between the points and show the pattern over time. So then if we move on to 2003, that dropped down here. So then we draw the dot and then we draw another line, and we can see it had a steeper fall there. 2004 goes to about 17,500, so that's about there, and then so on and so forth. So you continue to draw all of your points and you connect them along the way to show how that data has changed over time.